we've got two different ways to measure angles, so we need to take some time to figure out how to convert between these two forms, in particularly because for us, right, the sort of degree measure that's kind of more common and in some sense probably you sort of have a better intuition about is not the one that we're going to use quite as much as the radian measure, which is maybe new and it's going to take a minute to sort of get a good sense for how big these different values are. So our connection, right, is 360 degrees should be the same thing as 2 pi in radians. You know, that's right, sort of one full rotation in each of these units. This means then if we kind of cut those in half, I can get, you know, almost a little bit of a better measure, honestly, right, which would be sort of 1 pi would sync up with 180. And so then from there, depending on like how I divide, I can get two different like unit rates. So from here, so if I do a division by 180, I can sort of say that 1 degree would be the same thing as like pi divided by 180. If I divide both sides of this by 180, I'll be left with 1 degree is pi over 180 in radians. Or if I flip it around and I divide both of the sides by pi, what I would get is like 1 radian would equal 180 degrees divided by pi. Put a little RAD over here, right? Radians. I'm just putting the RAD in there just to signify which of these is radians. We kind of know, right, the degrees obviously have degree symbols on them, and I said before that radians are supposed to be this like unitless measure, so in some sense the whole point is not to have to mark units, but just for clarity on these like setups, I'll do that for now. What this means for us is that if we're trying to convert from one of these measures into the other, we're going to either use pi over 180 or we're going to use 180 over pi. You could set up ratios and stuff, right? I mean, you could do that too. But if we do this like multiplication, it's really a multiplication that turns into more of a fraction reduction than anything else. It's really a lot of reducing to lowest terms. So let's do a couple examples going from degrees into radians, right? My guess is we're going to have a little bit of a better intuition about how big an angle is in degrees before we really know how big it is in radians. So let's start with what we probably are a little more comfortable with. Let's take something like, I don't know, 60 degrees? And let's convert it into radians. So how do we do that? Which of these like two things are we supposed to do? So the idea is that, well, 1 degree, every 1 degree is going to be pi over 180 in radians. So what I'm going to do is I'm just going to take then 60 degrees, and so then if 1 is going to be pi over 180, 60 would be 60 times that unit rate. So this is going to be 60 degrees times pi over 180. And so you can see that what we sort of end up with here then, if I'm call this 60 over 1, so I sort of get pretty quickly 60 pi over 180. I of course don't want to leave it like that. This is going to reduce down a lot, so I can and should do that. The kind of obvious thing first is just the zeros would wipe out if we divide by 10. So this would be like 6 pi over 18. And then even from there, that's going to reduce further, right? Because 6 goes into 18 evenly. And would leave me with pi over 3. One thing, just like typically, almost all of our radian angles, especially at least the ones that we sort of see most often, are probably going to be fractions with a pi on top. Almost every radian angle is going to have a pi in the numerator. Not every single one, but like the most common form we're going to see a lot of fractions where it's pi over something, or something times pi over a value, right? 5 times pi over 6, for example. So expect that, right? Sort of know kind of what type of form to expect is going to help figure out which of these conversions to do. So 60 degrees would in radians look like pi over 3. That kind of makes sense if we think about the size of things. 60 right, would be kind of 180 divided by 3, right? So like if 180 is halfway around, if we cut that into sort of 3 chunks, 60 degrees would be sort of the first of those chunks. 180 is 1 whole pi, so pi over 3 is like 1/3 pi, right? So taking 180, cutting it into 3 chunks, and we're left with that like first chunk is that first 60 degrees would be pi over 3. Let's do, how about something a little bigger? How about 150 degrees into radians? So you can imagine this is going to have the same kind of setup, right? 150 degrees times pi over 180. So this setup is consistent. We'll probably think of this then as like 150 over 1. So 150 pi over 180, and then we have, again, the kind of very obvious conversion first, a reduction. This sort of zeros go out, right, dividing by 10. So this becomes a 15 pi over 18. That'll go again, right, because we could do 3 out of each. And this would leave us with 5, 6. Oh, there's that 5 pi over 6. That was not on purpose, but that was the angle I was just talking about. So there we go. I must have previsioned it. So that's another conversion. Let's do one more of these. And let me change 2 things. Let me do one that's a little bit bigger. I'm also going to do one that's negative. Let's do like negative 315 degrees into radians. So this is a negative angle. What that means is we're sort of rotating, right, clockwise. So almost sort of all the way around. The sort of picture would look something like that. But as far as doing a conversion, right, if I do a negative angle in degrees, I'm just going to get a negative angle in radians. So a negative angle is a negative angle in both systems. I just can kind of ignore the negative, and I'm really just going to work with the numbers. So this is going to be the negative version, right, 315 pi over 180. This is maybe a little bit less obvious to reduce. We could go by 5s, right? 315 and 180 are both reducible by 5. Let me try to think on my feet and figure out what these are going to be. What would 180 be? 200 would be 5 times 40. So this would be a little bit less than that. This is going to be 5 times 36. And then 315 on top. So you're going to have, right, 20, 40, 60. And then you're going to have 5 times 63 to get to 315. So the 5s go out of here. Get out of here, 5s. So this would be the negative version, 63 pi over 36. And thank goodness that's maybe not obvious at first glance, but both of these are divisible by 9, so that is progress. This would be 9 times 4. This would be, right, 9 times 7. So if we cut those 9s out of there, we're going to get, in the end, the negative version of 7 pi over 4. So I'm kind of on purpose trying to set us up with semi-decent angles, right? In a pinch, right, if you don't have an angle that reduces nicely, and you're getting, I don't know, or certainly if you're starting with some sort of decimal value, right, you could do these conversions on a calculator, but just as far as working with the trig stuff that we're going to be doing, we're going to be dealing a lot with these sort of standard radian angles, pi over 3, pi over 6, pi over 4, and the different like versions of that. And like we said, with 90, we saw it was sort of 1/2 pi, pi over 2. So that's going to be a lot of the type of angles that we're working with, more so than any decimal things. You can, of course, always do that in a pinch using a calculator, but we're going to focus on the more standard ones. Let's flip this conversion around, and let's go from radians into degrees. We just did negative 7 pi over 4. Let's take one that's maybe a little smaller and positive. Let's start with like 3 pi over 4. And let's convert it into degrees. I'll shift this back up to the top here for a minute, right? So we said 1 degree is pi over 180, so what we did is just say, well, however many degrees we had, we just multiplied by pi over 180. So we're going to do a similar move to go from radians into degrees, but we're going to use the opposite version, right, the reciprocal, because we're now going in the opposite direction. So 1 radian is going to be 180 degrees over pi. You can kind of get a little bit of a sense. So pi, right, is 3.14, yada, yada, yada. So 180 divided by 3.14 is going to be like a little less than 60 degrees, 57 or something. So you can get a sense. 1 radian is obviously much bigger than 1 degree, right? 2 pi would be kind of 6 1/4-ish, like radians, right? So 1 radian is like a decent chunk of rotation. So part of that, just the scale of these two units is very different. That'll help us with our setup a little bit. So I've got 3 pi over 4, and we said we're flipping it, so now we're going to use 180 degrees over pi. One of the things here that's sort of a dead giveaway that we're on the right track is converting into degrees. We're not going to expect to end up with a pi necessarily, right? And so part of what's happening here is the radian pi and then this sort of pi on the bottom in the conversion are going to get canceled out. We also are going to expect to get a much bigger number in degrees, right? We were just saying 1 radian is like almost 60 degrees. So a lot of our degree measurements are going to be much bigger numbers, which is sort of this 180 over pi. So this is like 3 times 180 over 4. And what we can do here is we can do just a quick reduction. I mean, really this is the 4 kind of dividing into the 180 more than anything else, right? I'll do this in chunks. 4 is 2 times 2. If I do 180 by 2, I would get 90, and then I can kind of just go another round, right? 2 by 90 is going to be 45. So this is really 3 times 45. 2 times 45 would be 90, so 90 plus another 45 would be 135 degrees. That's my final. That's how we do it. Let's do maybe 2 more kind of quickly. What didn't we see? We saw pi over 3, we saw pi over 6, we saw pi over 4. Let me do actually, how about 11 pi over 6 into degrees? So same kind of setup, right? 11 pi over 6 times 180 over pi. Pi cancels pi. So this is like 11 times 180. Don't actually multiply that, right? I mean, that's just going to get you a giant number that you're going to divide by the 6 anyway. So don't waste your time and scale it up if you're just going to cut it back down. 6 goes nicely into 180, right? 6 would go into 18 3 times, so into 180 would be 30. So this is 11 times 30. So that's going to be right. 10 times 30 would be 300. So this is going to be 330 degrees. So almost all the way around. That makes sense because this is sort of almost 2 pi, right? 12 over 6 would be 2 pi. So it makes sense that we're sort of almost at 360 and not quite. Let's pause there. I think you guys get the idea. So converting either way is really just a matter of using either this pi over 180 or coming for the other direction and using 180 over pi. Negatives beget negatives, and you can do this for sort of bigger and bigger angles if you want. We didn't do anything that was bigger than 360, but obviously that's possible, and it's not a big deal. You're going to just follow the exact same processes.